This is a demonstration of the hardware-software Codebug environment comprised of the Mentor-embedded Sorcery Codebench and Virtual Sorcery Probe for software debug, and Mentor Graphics Veloce emulator for hardware debug. To start, I'll run the Veloce graphical user interface and use that to download the design into the Veloce emulator. Then I'll run the Virtual Sorcery Probe, which connects to the processor's debug controller via a virtual JTAG interface implemented as a TestBench Express transactor. Lastly, I'll run the Sorcery Codebench IDE and use that to debug the software. The first step is to run the Veloce software, which provides the user interface to the emulator. All of the signals associated with the hardware accelerator are shown here. The next step is to download the emulation model to the Veloce system. The debug port of the processor is exported by the emulation model via a JTAG transactor. When the emulation starts and the JTAG transactor is ready, it starts a server which waits for a debug connection to be established by the virtual probe. After the emulation model is running and the virtual probe connects to it, we can run Sorcery Codebench to start debugging the software. The Codebug demo project contains a description of the target system, in this case we've named it Veloce DUT, plus the source code. The typical software debug cycle of edit, build, debug, repeat proceeds exactly as it normally would with actual target hardware. So I'll modify the program, rebuild it, and then start the debugger. The accelerator registers may be viewed in the register view. This shows that the control register full flag is 0 and empty flag is 1. Let's step into the process data set function. The while loop walks through the sample buffer, writing each data sample to the sample register. Then if the status is OK, it reads the results back from the results register. It carries on through this loop until it runs out of data or something goes wrong in the sample handshaking protocol. The status is OK. So now we'll read the results back. When we try to read the results, we see the status shows that something has gone wrong. Let's look at the accelerator's registers to see what's going on. So the control register is empty, as it should be after reading the result register, but it also shows that it's full. How can it be both empty and full at the same time? Since the hardware accelerator control register is in an unreasonable state, I'm starting to suspect a hardware problem. The hardware engineer wants to see what's happening in the design by observing the logic state on key signals over time in a waveform view. In order to capture these waveforms at the right point in time, a trigger is defined for the condition we observed. Now let's resume running the program. Notice now that the emulation run is done. This view shows that the trigger event was detected and the emulation run was stopped. So the whole design is frozen at that moment in time. Now let's upload the waveforms and look at what was happening in the hardware when the empty and full flags became conflicted. The request is low and the write is high, so we're doing a read. Register select is 2, so we're reading the result register. The result register value here is read onto the read data bus, so we're correctly reading the results. Meanwhile, the empty flag goes high, indicating that the accelerator is empty now, but the full flag stayed high. That confirms what the software engineer suspected. A problem in the hardware accelerator causes it to look like it's empty and full at the same time. And the problem happens directly when reading the result register. Since the problem was triggered when reading the result register, let's look at the source code associated with that. But here, when the register select is result, and we're reading the result register, we see the empty flag go high, as we saw in the waveform, but the full flag is not being cleared. So a missing statement in this logic block is responsible for the handshaking protocol violation. This demonstration showed some of the benefits of hardware-software code debug using Sorcery Codebench and Virtual Probe in conjunction with the Mentor Graphics Veloce system.